Okay, so in this video, I'm going to show you two problems where you use the derivative to determine where the original function increases and decreases, but then more importantly has relative maxes or relative mins. So obviously the first thing you're going to do is take the derivative. And this is a pretty easy one. It's just a polynomial, and so you can just use the power rule. So we get 3x squared minus 12 for the derivative. Now, the next thing we're going to do is we're going to find our partition numbers. And remember, the definition of partition numbers are any numbers that make the derivative equal to 0 or make the derivative undefined. Okay? Now, our derivative is also a polynomial, so it will never be undefined. The easiest way to think of that is it doesn't have a denominator, and so you can't divide by 0. So we don't have to check the second case in this problem. So all we're going to do is set our derivative equal to 0, and then we're going to go ahead and determine what our partition numbers are. So our derivative is equal to 0 when 3x squared minus 12 equals 0. And to solve that, you add 12 and then divide by 3, and you get x squared equals 4. The mistake that you're going to make right here is that when you take the square root of both sides, you're going to forget the plus or minus. So this would be x is equal to plus or minus 2. So we have two partition numbers. So we're going to go ahead and make a number line for our derivative. And we're going to put our two partition numbers on there. Both of these partition numbers make my derivative 0, so I'm going to put a 0 above them. And I'm going to label my number line that it's the derivative, because if we ever come back to school from the snow, we'll be learning about the second derivative test, and then we'll have to label this the second derivative. The one thing that I probably would do before I started doing my sign chart, and again, this is completely up to you because this one's pretty easy, is you could factor your derivative into, like, if you wanted to, let me kind of bring this down here. If you wanted to, you could factor out the 3. And again, probably on this one, I wouldn't waste my time because this is pretty easy. If you wanted to, you could fully factor it and then do your sign chart there. So either choose if you want to plug your numbers in there for your sign chart or in here. It doesn't really matter. If I put a 0 in, I'm going to get a negative. If I put something like -5 in, when I square it, it becomes positive. Then I multiply it by 3 and subtract 12. So this is going to be positive, and then this is going to be positive. So what that tells you is your original function is increasing from -infinity to -2, and then again from 2 to infinity. And then your original function is decreasing from -2 to 2. Okay, that's all that we did before. And then what we've added on is this part. Okay, you have to check now that your partition numbers, you have to ask yourself, are they critical values? And what that means is when you plug them back into the original, so you're going to take your partition numbers, you're going to put them back into the original, and do they make the original undefined? If they do, then they are not critical values. And what that means is they cannot be a relative max or min. Okay, so I don't have to say it again because you can pause the video and rewind that, but that's super important. If your partition numbers are not critical values, they cannot be relative maxes or relative mins. So what you're going to do right now is take -2, plug it back into the original, take 2, plug it back into the original, and just make sure you're not dividing by 0. And in neither case are we dividing by 0, so that means that both of my partition numbers are critical values. So x equals -2 and x equals 2 are critical values. Now, if we go back here to our sign chart, we can see that our sign chart goes from being positive to negative. So that means our graph goes from increasing to decreasing at -2. That means that -2 is a relative max. And if we go back here, our sign chart goes from negative to positive, so our graph goes from decreasing to increasing at 2. And by the way, you could see that our derivative is 0 at those places, so that's how we know we have horizontal tangent lines right there. So anyway, this is a min, right? So then we know that x equals 2 is a relative min. And then if we go and look at the graph of this function, we can see that that's true. So if we look at the graph, we can see that there is a relative max at -2, and there's a relative min at 2. All right, now, more importantly, because that one was pretty straightforward, here's the one that I want to show you that a lot of students have trouble with and even understanding it. So let's do the same thing with f of x equals x over x minus 3 squared, okay? So I'm going to go ahead and take the derivative using the quotient rule. So bottom times the derivative of the top minus the top times the derivative of the bottom. That's chain rule, right? And then all over the bottom squared. So it's going to go from being squared to the fourth. Okay, so a couple of things are super important here. We need to clean up this derivative. We need to simplify it, all right? So one of the first things I would do is I would check for a GCF, especially in this case, because it's really obvious that there is one, right? We've got this x minus 3 squared, and we have this x minus 3. It's really important to make sure that you factor that out, because it's going to simplify with the x minus 3 to the fourth in the bottom. And then that way, what you won't get is what happened on your last test, where you thought that 3 made the derivative both 0 and undefined. That's not possible, okay? So it is super important to go ahead and factor this now. So up top, I'm just going to keep saying this is my derivative because I'm not setting it equal to 0 or anything. I'm going to take out the GCF of x minus 3, all right? And then what I'm going to have left over is one of these x minus 3's minus, and then here I lost the x minus 3, but I still have a 2 and an x, so I would have minus 2x. And then in my denominator, I would have x minus 3 to the fourth. Now this is where it's super important to go ahead and simplify those x minus 3's. So up top, I have negative 2x plus x, which is negative x, and then minus 3. And then in the denominator, I have, and then like I said, these simplify right here. Okay, and you get x minus 3 cubed. So now my derivative is pretty simplified. If you want, it might not be a bad idea to factor out a negative up top, and also to show yourself that that actually isn't going to cancel with the bottom, because it looks like a little bit tempting to just go ahead and reduce the bottom to a squared and the top to like a 1 or a -1, but it actually doesn't do that. So it might not be a bad idea to do this, especially when you're making your sign chart. So there's my derivative. Okay, so here we go, partition numbers. My partition numbers are where my derivative is 0. So that's where I have a fraction. So all I have to do is set my numerator equal to 0. So I get x plus 3 equals 0, and I get x equals -3. So that's one partition number. My other partition number is, or numbers, is where my derivative is undefined. So I set the denominator equal to 0. And I get a partition number of 3 down there. Okay, so now we just make our number line. It doesn't matter yet if these are critical values, so don't even check. Just make your number line. -3 made my derivative 0, and +3 made my derivative undefined. And then if I go ahead and make a sign chart, let's see here, a -4. So this would be negative times a negative over a negative. So we got a positive over a negative. This is negative. If I plug in 0, I get negative times a positive over a negative, which is a positive. And then if I plug in 4, negative times a positive over a positive, which is a negative. Okay, so we know that, let me get rid of these. This was just me kind of thinking out loud. So I'm going to go ahead and write my increasing and decreasing intervals. Okay, and again, this is all from what we learned before. So f of x is increasing from -3 to 3, and then f of x is decreasing from negative infinity until negative 3, and then again from 3 to infinity. Okay, now we've got to go critical values now. This is where things are going to get gross. Both of these are partition numbers. However, if you plug them back into the original, positive 3 is going to make the original undefined. So while x equals 3 and negative 3 are partition numbers, that means they go on our number line, only x equals negative 3 is a critical value. So what that means is positive 3, only positive 3, you'll notice that I'm changing signs here, right? My function is going from increasing to decreasing, but since 3 makes the original undefined, this is not a relative max, okay? So there's not a relative max there because what's actually there is if you go back to the original, f of x has a vertical asymptote at x equals 3. Whoa, glitch. At x equals 3. So what that means is x equals 3 cannot be a relative extrema, a max or a min, because literally the graph doesn't exist there, okay? So what's happening here is the only thing that's happening is we go from decreasing to increasing at negative 3. What that means is x equals negative 3 is a relative min, and there's no relative max. So if we take a look at the graph, I'll show you what that looks like. There's going to be an asymptote on it. So let's go back to Desmos here, and let's do f of x equals x over x minus 3 squared. And what you'll see is it's really hard to see the max here, or the min. So like here at negative 3, there's a min, but that's like impossible to see on the graph, honestly. I just know it's there because we did the calculus. But if you look here, see how this graph goes from increasing to decreasing, but there's no max because what happens is there's just a vertical asymptote. The other way that you can cheat a little bit and check to see if there's a relative max or min that you can't really see and you think it's at 3 but you're not sure, do this. If you type in f prime of x, it'll graph the derivative, and then you can check to see if the derivative is 0 at that point, and it is, right? So just a little bit of cheating because I didn't know it was there. If I would look at this graph, I'd have no idea that there's a min there, and then it starts going back up. I mean, you could kind of like drag the cursor or whatever, but the easiest way to do it is, hey, let's see if my derivative is 0 at negative 3. So I'll just hit the graph for the derivative, and then if I come over here and I click at negative 3, it is 0. Okay, so finish up the worksheet 1 through 12. Do what you can, get all the partition numbers and critical values. If you have trouble matching the graphs, that's fine. Period 3, you don't even have the graphs, so we'll do that next week. And just go ahead and email me with any questions.